Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah and today we are going to discuss screw gauge. Let me recall the previous work what we have done yesterday. If you remember, in the previous lecture we have discussed measuring instruments. We have discussed with vernier calipers, right? Now today we are going to discuss with screw gauge. If you remember in the previous lecture, vernier calipers we have discussed, which was an instrument which is used to measure a small length, right? Okay, and thickness of internal external diameter, and this all length we were using with vernier calipers we have discussed in the previous lecture. Now in the today's lecture we are going to discuss what is screw gauge. Before going further, we need to understand what is the historical background of the screw gauge. Historical background of screw gauge is, look, screw gauge was invented by William Gascoigne in 17th century. Okay, now what is the basic definition of screw gauge? Screw gauge is a kind of an instrument which is used to find out the thickness of a thickness, or you may say diameter of a solid sphere, and it is an instrument which can measure accurately length up to 0.01 millimeters or 0.001 centimeters, right? So 0.01 millimeters or 0.001 centimeters length can be very accurately measured using a screw gauge. Done ho gaya? Okay. Do remember one thing, screw gauge is also known as micrometer screw gauge. Okay, its other name as well. Okay, what is the construction of screw gauge? Basic construction of screw gauge is, if you look, it has a the constructive part of this screw gauge is, the constructive part is, the first is U-shaped metal stud, and this is hollow cylinder. It is also known as sleeve. This is spindle, this is anvil, this is sleeve, this is thimble, this is ratchet, this is main scale, or you may say linear scale, right? This scale, this thimble has a reading in millimeters, right? Micrometer scale in 0.01 millimeter scale. Done ho gaya? Okay, and this black line is also known as index line, or you can call it a datum line as well. Done ho gaya? Okay, now let's come towards the scales in screw gauge. There are two scales in screw gauge: circular scale and main scale. Do remember one thing, this main scale is fixed scale, while this circular scale has a rotating scale on the main, this circular scale actually rotates on the main scale. Done ho gaya? Okay, now circular scale, thimble has 100 divisions around one end. Okay, it has 100 divisions around one end. It is circular scale of what? Screw gauge, right? As the thimble completes one rotation, means 100 division pass the index line, and thimble moves a distance of how much? 1 millimeter distance along the main line. Like if you rotate this circular scale, okay, this thimble completes 1 millimeter distance on this main scale division. Done ho gaya? Okay, now main scale may have divisions, 50 divisions as well, it may have 100 divisions as well. Okay, so accordingly least count also changes, right? So if you have 50 divisions, so least count will be 0.5 millimeter. If you have 100 division screw gauge, so its least count will be 0.01 millimeters. Okay, now mostly we use 100 divisions containing screw gauge. Okay, now what is pitch of the screw? Pitch of the screw is actually a distance completed or covered by circular scale or main scale by giving one complete rotation to the circular scale. That distance is known as pitch of the screw. You can also define it like this: the distance covered by one complete rotation of circular scale on main scale, that is known as pitch of the screw. We can also define it like this: as the thimble completes one rotation, the spindle moves 1 millimeter distance along the index line. This is because the distance between consecutive thread on the spindle is 1 millimeter. This distance is called pitch of screw. Okay, now let's come towards least count. We know that least count is the distance, the minimum distance that can be measured by using a certain device is known as least count of that device. Now we are going to discuss least count of what? Screw gauge. Okay, least count of screw gauge can be defined as the ratio of pitch of the screw to the total number of divisions on circular scale. We can define it like this as well: the ratio of pitch of the screw to the total number of divisions on circular scale. Pitch of the screw may be 0.5 millimeter as well if you are using a screw gauge with 50 divisions on circular scale. Okay. Now, if you are using a 100 division screw gauge, so its pitch will be 1 millimeter. So you will divide it by 100. In both the cases, you are going to get 0.01 millimeter. So this 0.01 millimeter is what? This is pitch of the screw. Okay. Now coming towards zero error. As we have discussed in the previous lecture about vernier calipers, there was also zero error over there. Okay, now in screw gauge we also discussed zero error. What is zero error? If zero of main scale does not coincide with zero of the circular scale, this error is known as zero error. What we say? Look, if zero of the main scale does not coincides or matches with zero of the circular scale, this error is known as zero. This error is known as zero error. Now there are further two types of the zero error: positive zero error and negative zero error. Positive zero error is that zero error in which circular scale exists behind the index line. What is positive zero error? If circular scale exists behind the index line, yeah, you may say datum line, that error is known as positive zero error. Okay, how to correct this error? This error is always subtracted from the original reading. Okay, coming back towards negative zero error. What is negative zero error? If circular scale has crossed the index line or datum line, if circular scale has crossed the index line or datum line, such type of error is known as what? Negative zero error. How to correct this type of error? Do remember one thing: negative zero error will be always added with the original reading. Done ho gaya? Now we are moving towards that side. Okay, we are moving towards that side. Okay, the question is how to take reading with screw gauge, like how we are going to take reading with screw gauge. Okay, there are some of the steps. First step is note the pitch of the screw and least count of the screw. Done ho gaya? Note pitch of the screw and least count of the screw. Done ho gaya? Okay. Find the zero error. If it has zero error, do zero correction accordingly. Like if there is zero error, so definitely the error may be positive zero error, or you can say negative zero error. So do correction accordingly. If it is positive zero error, subtract it from the original reading. If it is negative zero error, add it with the original reading. Done ho gaya. Okay. Now what is third step? Place the object between thimble and anvil. You have to place the object between thimble and anvil. Like you will place the object over here. We can place the object, for example, solid sphere over here like this. Done ho gaya? Okay. Now turn the ratchet until the anvil and spindle gently grip each other. Okay. Now what we do? We have to turn the ratchet so that anvil and spindle may grip each other, like grip the object very properly. Okay. Then turn the ratchet until it starts to click. Like you have to rotate it so that the object will be clicked over there. It will be tightened strictly over there. Okay. Now come to fourth point. What is then? Note the main scale reading as well as circular scale reading. Okay, you have to note the main scale reading as well as circular scale reading. Okay, now what is the next step? Next step is multiply the circular scale reading with the least count of the screw gauge. You have to multiply the reading obtained on circular scale with least count. Okay, now what is sixth step? Now add the result, whatever you get by multiplying least count with circular scale, you will get some result. Now what to do that result? Now add the result with main scale reading. Whatever reading you have got with main scale, add it with it. Okay, now which is the required diameter of the sphere. So this will be required diameter of the sphere in the units of millimeter as well. You can take in centimeter, convert it in centimeters as well. Now you can say that diameter of a sphere is equal to main scale reading plus circular scale reading multiplied by least count of it. This was all about screw gauge. We have to this was all about today's lecture. Okay, now let me summarize today's work. What we have done today, we have discussed with screw gauge. The historical background was it was invented by William Gascoigne in 17th century. It is the instrument which is used to measure thickness or diameter of a solid cylinder, right? And you can define it like this as well. The instrument which is used to measure the length very accurately up to 0.01 millimeter or 0.001 centimeters. Done ho gaya? Okay. Now, it's also known as micrometer screw gauge. Okay, construction, it has U-shaped metal stud and a hollow solid cylinder, what we call sleeve as well, and a central line is known as what? Datum line, you can say index line as well. Okay, this was anvil, this was spindle, this was sleeve, this was main scale or linear scale, this was thimble, this was micrometer scale in 0.01 millimeter, this was ratchet. Okay, so what is pitch of the screw? Pitch of the screw is the distance covered by circular scale on main scale by giving one complete rotation to circular scale. Like if you give one complete rotation to circular scale, how much distance it has covered on the main scale, that distance is known as pitch of the screw. Pitch of the screw can be 0.1 millimeter as well, 0.5 millimeter as well, and 0.01 millimeters as well, depending upon the type of screw gauge you are using. If you are using 50 divisions containing screw gauge, so its least count will be 0.5 millimeters, and if you are using 100 divisions screw gauge, so it will be 0.01 millimeters, so its pitch will be 1 millimeter. Done ho gaya? So when you divide both the terms, in both the cases you are going to get least count 0.01 millimeters. Then okay, there is zero error. What is zero error? If the main scale 0 does not coincide with the circular scale 0, so that is zero error. So this now it has two types: positive zero error, negative zero error. If what is positive zero error? Circular scale. If the circular scale exists behind the index line, this is positive zero error, and it will be always subtracted from the original reading. What is negative zero error? If circular scale has crossed the index line, this error is known as negative zero error. Okay, do remember one thing: negative zero error is always added with the original reading. Now, how to take reading through screw gauge, which is the most important part. First of all, number 1, find the pitch and least count of the screw gauge. Number 2, find the zero error, do zero correction as well. Number 3, place the object between thimble and anvil and fix it by ratchet so that it will start to click. Okay, now note the main scale reading. Note the main scale reading. Done ho gaya? Keep it at one side. Okay. Now note the circular scale reading. Done ho gaya? Whatever reading you get in circular scale, multiply it with the least count of the screw gauge. You are going to get some result. Now that result will be added with the main scale reading. Okay. So as a result, finally you are going to get diameter of a solid sphere, you can say. So what is the method? Main scale reading multiplied by circular scale reading multiplied by least count of it. So this was all about today's lecture. Hope you have enjoyed it. Thanks for watching. Allah Hafiz. Fi Aman Allah.